Hello everyone. In this video series, I want to write a Blink program for the Arduino Uno development board. The board contains a atmega328p microcontroller from Atmel or from Microchip. Um, I am not going to write any program that blinks. I want to make it as small as possible. Um, So let's first see the program that we have in the Arduino software. It comes with a built-in Blink program. Let's see it. We can find it in, excuse me, under File, Examples, Basics, Blink. To know the size of the program, by the way, the program is very obvious. It sets the pin that contains LED as output, and then it turns it on, wait 1 second, turn it off, wait 1 second, and do this over and over and over forever. If we compile this, the Arduino program is going to tell us the size. Here it is. Sketch uses 924 bytes out of total this number 32,256 bytes. So 924 bytes just to blink a simple LED. Yeah, that's too much. So let's try to make it short. Small. Now we don't know what's going on here. We don't know who is calling setup function. We don't know what is inside pin mode, and the same thing for digital write and all of the others. So I decided to write my own .c file, and then I will compile it using the AVR GCC compiler. To do that, I have created a project in VS Code. I wrote several programs, which each of them is smaller than the other. I also wrote this makefile that have two rules. The first one is to convert any .c file to .elf file or executable and linkable format. We have to use this command avrgcc, the input file, and then -o, which stands for output, the output file, and then and then we tell the avrgcc what the type of microcontroller we are trying to generate code for it, because there are different type of different architecture within the AVR, different instruction set. So we have to tell the AVR GCC, and this will generate something called .elf file. This .elf file contains more other information than just the actual instructions. So to extract the raw binary, only the instructions, we use this program avr-obg copy-output binary, and then the elf file that we want to convert, and then the name of the output file that we want for the binary. So let's have a look at the first program. We have few definitions. I am defining fCPU. This is for the delay function. It needs to know the frequency that we are running at in order to determine how much to make a loop. It basically generates some loops based on the frequency that we tell. And then I have some definitions. Don't worry too much about it. You can ignore that in your program. I just included it to make VS Code happy so that it doesn't show error for these definitions. Now let's see what the code is doing. The first instruction is set all the pins of port B as output. In order to write something to the port, we have to first configure it as output, and to do that we write 1 to the data direction register. By the way, the pin that we want to turn it on and off is the pin 5 of port B. In order to see that, we can go to the Arduino Uno schematics. This is it. If we zoom in PB5, we can see that it is connected to an LED, and also it is pin number 13 on the Arduino Uno board, but on the microcontroller it is PB5. But here I'm just turning everything on. This is not a good thing because we may overwrite the usage of the other pins. In this case we don't care, but normally speaking we want to only set the individual bit, the fifth bit in this case. And the other thing why this is not good is because there is actually a simpler way to set only one bit. We will see that in the other files as improvements. And then in the while loop, I'm just setting port B as out. I am setting port B like 111, all of them, so that I turn on the PB5. Again, there is a better way to do this, but for now let's just stick with this one. Obviously then delay 1 second, 1000 millisecond, which is equivalent to 1 second, and then turn it off, delay for another 1 second, and repeat everything. So let's compile this program and see the size of the output file. So I'm gonna compile it. I'm gonna write make blink1 a .elf. I'm going to create multiple versions of the elf. You will see. No rule to make target blink1.elf. What happened? Yeah, because it's not gonna find blink.c, but let's just create blink1. We have created it. It is giving us some warnings, but we don't care for now. Let's see the size of the elf file. ls blink1.elf. It's 8420. But don't worry, this is just the size of the elf file. It contains a lot more information than the actual instructions. In order to find the actual size of the instructions, we can use AVR size and then the name of the elf file. We have generated 1204 bytes, which is actually worse than what the Arduino software generated. So I'm gonna make some improvements to this file, but before that, let's keep track of the size of each file. So from the Arduino Uno, from the Arduino program, we got 924 bytes. 924 from Arduino software. and from the blink one we got 1204. This is without any optimization. Okay, let's try to improve it. I mean, before we improve it, let's see let's disassemble and see what is inside the blink1.elf. In order to do that, we can use avr object dump dash d blink1.elf. So this is the assembly behind our program, the assembly that is generated for this program. As we can see, we have a lot of subroutines that we don't know where they come from. Probably they come from the util.h file. Yeah, that's pretty big. I'm trying to find the main. This is the actual program that we wrote. But still, everything is too much. So let's try to use some optimizations. In order to do that, let's go to the makefile and add the OS, which indicates for optimize for size. And now if we let's remove the blink one first and then make it. I make it. Let's see the size. AVR size 178 bytes. Wow, that's very impressive. Let's write it here. 178 with size optimization. Let's see the internal assembly code for this file using AVR. If we make this bigger, we can see it is actually a lot smaller. We have few functions. One of them is the vector, and another one is constructors and the bud interrupt handler. What is it doing? Let's try to disassemble it again. Yeah, now it's a lot clearer. Clearer. We have the vector table. We have some initial code, some bud interrupt handler, and our main code, obviously, and then some other functions that we didn't add at all. So far that's very good improvements, but we can actually improve this more by getting rid of all of the other code, including the vector table with the initialization of stack pointers and stuff. I'm gonna explain what this code is doing in the next video, but there is a way to get rid of it. Before we get rid of everything except the main, we have to know what it is doing, so that we make sure that it doesn't affect our program. But that one is going to be for the next video. But for this video, we have reduced our original code from 1204 to 178. Like I said, in the next video we will get rid of everything else except the function that we wrote, this one. So I will see you there. Thank you.